Hello class, welcome to Unit 7, Video 7. Today we're going to go ahead and look at solving polynomial equations. So we've been working with polynomials all unit. We just got done looking at how to graph polynomials. So now we're going to go ahead and look at how to factor polynomials. So your learning target is that you can factor polynomials, and after you learn to factor, you're going to learn how to solve polynomial equations by factoring. So we've already looked at factoring, so some of this will just be review. Okay, so factor the following quadratic equations. We have done this in the past. So looking at number 1, we have 2x squared minus 7x minus 15. I know I need to factor because it's a quadratic. And then since there is a 2 in front, I know I'm going to have to do a little guess and check. So remember, the number in front of this has to multiply to 2x squared. So what multiplies to 2? Well, 2 and 1, so I know I'm going to have 2. And then what multiplies to x squared? X and x. Then what's at the end, and I'm going to use a different color, has to multiply to negative 15. So this is where the guessing comes in. I'm just going to pick, I know 1 times 15 is 15 and 3 times 5. So right now I'm just going to try 3 and 5. Okay, that's how that works. Then in order to get our middle number, okay, that comes from when I check these two, my outer and my inner. So 3x when I multiply, and this one gives you 10x. With these two, could I add to get to negative 7x? Well, if this was negative, negative 10 plus 3x is negative 7. So I would have negative, positive. So here is my answer. My answer is 2x plus 3 and x minus 5. So there's number 1 factored. Okay, moving on to number 2. I look at this one. This one is not a quadratic. It is a polynomial. And so I see that I'm going to have to take a GCF out of this one. So 25 and 15 are both divisible by 5. So I know I'm going to have a 5. A to the third and a to the second, I take out the smaller of the exponents, so a squared. B to the fifth and b to the sixth, so I can take out a b to the fifth. Okay, so remember this is our GCF problem, greatest common factor. So 25 divided by 5 is 5. A to the third times a gives me a to the second times a gives me a to the third. B to the fifth times 1, so I don't need to add anything. So plus, moving on to this piece, 15 divided by 5 is 3. A squared times 1 would give me a squared, so there is not going to be an a squared. B to the fifth times what gives you b to the sixth times b. So there is my example, or my solution for number 2. Then number 3, x squared, perfect square. The square root of x squared is equal to x. The square root of 81 is equal to 9. So this is, remember, our special case. It's our difference of perfect squares. Difference, remember, means subtraction of perfect squares. All right, so I would factor this one. Remember the way it is I have my two sets. I have x and x. Square root of 81 is 9, so I have 9 and 9, and then I always have a plus and a minus. So there is number 3. Difference of perfect squares, that is something that you should remember from last try. So when factoring polynomials, take out the GCF, greatest common factor, first. That's like number 2 that we did. Then factor the result if possible. Okay. Factor patterns of polynomials with 2 terms. So difference of 2 squares. We just did an example like this. This was number 3 on your note sheet. So we know that one. That one is old. The next 2 are new. You need to know all of these equations. You will not have a sheet. You need to memorize all of these. Memorize all of them. Okay. They're really not that bad. The first one you should have down. The next one, notice it's cubes. Okay, so if I have a perfect cube and a perfect cube. The difference is one's being added, one's being subtracted. Then if you look, everything here in terms of the letters matches up. The only thing that is different is, okay, this one has addition. So it starts out with addition. The second thing is subtraction and then addition. Okay, this one has subtraction. So the first thing is subtraction and the rest are addition. So there's only one negative in each. It just depends on where it is placed. So we're going to get some work done in with these, and then you will maybe feel more confident with the equations. But you will need to memorize those and know those for your test. So let's just look at some examples. Okay, so it says factor the following polynomials. Right away I look at it and I see that there's only 2. I see it's a cube. Okay, well, when I see it's a cube, I'm like, okay, well, I know that the cubed root of 3x to the third is x. And I know the cubed root of 125 is 5. So that means I can use the sum of 2 cubes formula. Sorry, my calculator's pulling up here, so just give me 1 second. One thing I want to point out is maybe you don't know the cubed root of 125. So my instinct would be just check it on your calculator right away. The way you check it is you go math. See how number 4 is a cubed root? Arrow down to number 4. Plug in 125, and you will see that the cubed root of 125 is 5. All right, so I know I am going to have to use my sum and difference formula. I'm just going to plug it up here. So for this one, I see sum, so that's why I know I have to use this one. Okay, so what I would do is this part right here is my a. So a to the third is equal to x to the third. So that means that a is equal to, if I take the cubed root on both sides, x. Then b is equal to, b to the third is equal to 125. If I take the cubed root on both sides, which I did on my calculator, I get b is equal to 5. Then I just need to plug it into this formula. It's a plus b, so x plus 5. Then I would have my a squared, so x squared minus a times b, so 5 times x, so 5x, plus my b squared, 5 squared, which is 25. There is my difference of perfect cubes factored. Okay. I move on to number 5. I see, once again, 2 pieces, and I see perfect cubes. It's subtraction, which tells me I'm going to have to use this equation. Okay, so let's just try it. So a cubed, which is the front piece, is equal to 8x to the third. Once again, maybe you don't know what the cubed root of 8x or 8 is. So I go on here. I go math. I go down to number 4. I type in 8 and hit enter, and it is 2. Okay, so that means that a is equal to the cubed root of 8, which is 2, and the cubed root of x to the third, which is x. B cubed is equal to 27. The cubed root of 27, most of you probably know is 3, but if you don't, once again, we go math, number 4, and I type in 27, which is 3. So my b is equal to 3. Okay, so it's always a and b in the first parentheses, and this one's subtraction, so it's going to be a minus b. So it's 2x minus 3, parenthesis. Now it's my a squared, so we got to be careful here. It's all of a squared minus, this is subtraction, so plus a times b. 2 times 3 is 6, so it's 6x, plus our b squared. 3 squared is 9. Now I need to simplify just a little bit. I have 2x minus 3. 2 squared is 4x to the second, plus 6x plus 9. And there is example 5. Okay. Moving on to example 6, we have a squared minus 49. Okay, well, this is great. Let's go ahead. And we're going to use, since it's an a squared, I'm going to guess we're going to use difference of perfect squares. So, a squared, my first part is a squared, so I would say, well, what is the square root of a squared, which is a? And then I would say, what's the square root of 49? 7. So I'm going to have a plus 7 and a minus 7. Okay. The next one looks a little trickier. I see that it's an even though, so I'm gonna try difference of perfect squares. Okay. So in this case, a squared is equal to x to the fourth, and b squared is equal to 81. So if I take the square root, that means a is equal to x to the 4 divided by 2 second. B is equal to 9. So I have x squared plus 9 and x squared minus 9. using my difference of perfect squares. Now I look at this one and I see, oh, x squared minus 9. The square root of 9 is 3. The square root of x is x. So I can break this one down even further. So this piece becomes here. This is x and x. The square root of 9 is 3. And then I have plus and minus. And that is my completely factored example for number 7. Okay. Moving on to 8 and 9. Okay. I have x to the fourth, x, and then we have just a constant or a number. These can be solved very similarly to x squared minus 23x minus 50. The only difference is before my front had to multiply to x squared. Now we need to multiply to x to the fourth. So I'm just going to start it out with x squared and x squared. Okay, and then I do 50, factors of 50. So there's a 1 in front. So I say what multiplies to 50 but adds to 23. Well, 23 and 2, that would, or sorry, not 23, 25 and 2. This would then be, if I want to add to negative 23, negative positive. Okay, and let's check to make sure it works. This times this, that gives me x to the fourth. Negative 25 times 2 gives you negative 50. And then this gives me negative 25x squared. This gives me 2x squared. When I add them, do I get negative 23 to the x, 23x to the second? Yes. Okay, so the biggest thing that's different today is now I have an x to the fourth term, which I can do the same as a quadratic, but now I just need to go ahead and put an x squared in the front when I'm factoring. However, I look at this one. This is our difference of perfect squares, so I need to break that down. I would say the square root of 25 is 5. And I always have a plus and a minus, and I still need to write the extra piece, x squared plus 2. So there is my number 8 factored all the way. I would like for you to pause the video and try number 9 on your own. Hopefully you paused the video and did number 9. So it's an x to the fourth, so I have x squared in the front. I need to multiply to negative 63, but add to 2. Right away when I think 63, I think 9 times 7. Okay, if I want to add to 2, that means this has to be positive and this has to be negative. Okay, I look, is there any difference of perfect squares? This one looks like it, but it's addition, so I can't break this down any further. This one is, but the square root of 7 is not a perfect square. So I'm actually done with this one. That's all I can do. Okay, so that is example 9. Now we're going to go ahead and switch to solving quadratic and quartic equations using techniques that we've done already. So if you want to break, now's a good time. Otherwise, we're going to go ahead and finish up the notes. Okay, solving quartic equations using quadratic techniques. So quartic means something to the fourth power, and our quadratic are something to the second power. So we're going to use a lot of the same ideas as we did when we were solving quadratics. All right, so I have x squared plus bx plus c equals 0. So we want to factor it so that we multiply to c but sum to b. Okay, so when we factor, we want to multiply to this but add to this term. This was with our quadratic. Same thing is true with the quartic, except for instead of just having x, we have x squared. Still want to multiply to the c but add to the b. So let's go ahead and use that idea. So we're going to solve. So this one, I look at it. This one is a quadratic, x squared. So I'm going to have x and x equals 0. And now I think to myself, okay, what multiplies to negative 14 but adds to negative 5? If I'm not sure, I'm just going to write down 14 and say, well, 1 times 14, 2 times 7, and those are my only options. Okay, I need to add to negative 5, so I know 2 and 7 is what's going to make it work. I need it to be negative 7, so there we go. Then to solve, that's the biggest piece we're doing now is we're solving. Take this, set it equal to 0. Take this, set it equal to 0, and solve. So I get x is equal to negative 2 and x is equal to 7. Those are my solutions. Okay, let's go ahead and look at number 11. That one looks like a quartic, so we're going to use the same strategies, but we're going to have an x squared in the front of each. So what multiplies to 36 but adds to negative 13? 36, The first one that comes to my mind is 9 and 4. 9 times 4 is 36. So would that work? That would. To add to or multiply to a positive, we both have to be negative, and negative 9 minus 4 is negative 13. Now I look, do I have any difference of perfect squares? Yes, I do. The square root of 9 is 3 and the square root of 4 is 2. So let's break it down. They're both being subtracted, so I have x plus 3, x minus 3, and x plus 2, x minus 2. Okay, so here I have this. Now I'm solving because it's equal to 0. So when I solve it, I have x plus 3 equals 0, x minus 3 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So when I solve, I get negative 3, positive 3, negative 2, and positive 2. Those are all of my solutions. Okay, that is number 11. Let's go ahead and look at number 12. Once again, I see it's a quartic. So I'm going to have an x squared in the front of each. Okay, if I have an x squared, well, it multiplies to 225 but adds to negative 34. So right away, I'm like, I have no clue, but 225 looks like it's divisible by 25. So let's just try it. 9 and 25. Could I get to negative 34 with that? Yes, I could. So I'm going to use that. So I would have 9 and 25. And I would think to multiply to a positive but add to negative would both be negative. Okay, once again, difference of perfect squares. So I could go ahead and break it down like I did in example 11. Another option is I can set them equal to 0 now. Okay. And I would just have to use the square root property in order to solve this one. So I'd add 9, so I have x squared is equal to 9. And then remember, when you take the square root, we have two answers, plus or minus the square root of 9. So x is equal to positive or negative 3. Same thing happens here. I would have x squared is equal to 25. Then I would take the square root. When you take the square root, you get two answers, plus or minus the square root. So x is equal to positive or negative 5. So you could have did the same thing on number 11, or you could do the difference of perfect squares on number 12. Either way, if you wanted to do it, this one would factor down into x plus 3, x minus 3, x plus 5, x minus 5, because they're both difference of perfect squares. Then you'd set them all equal to 0 and get your answers. So for 11 or 12, there's kind of two ways to approach that one. You can pick which way you prefer. All right, last one, number 13. I see this one as a cube. Right away, I see that it is addition. So the addition piece tells me I'm going to use the sum formula. Okay, so let's figure out what a is. So a to the third is equal to x to the third. So when I take the cube root, a is equal to x. Then I see b is equal to 64. So, sorry, b to the third, looking at this piece. I would take the cube root of 64, and I would get that that is 4. Once again, remember, if you don't know, my calculator, I already shut it off. So if you don't know, you can go ahead and plug it into there. Oh, that opened a lot quicker than I thought. So if you didn't know, you go math, number 4, arrow down or hit number 4, and then type in 64. Cube root of 64 is 4. So there we are. Now I'm just plugging it in. So it's a plus b, so x plus 4. Then I have this piece here, x squared, or sorry, a squared, so x squared minus these two multiplied, 4x, plus my b squared, 4 squared is 16, equal to 0. Now I'm solving, so I need to take each part and set it equal to 0. X plus 4 equals 0, and x squared minus 4x plus 16 equals 0. This gives me negative 4. There is one solution. Now I try and factor this one, because I see it's a quadratic, multiplies to 16 but adds to negative 4. The only things that multiply to 16 are 1 and 16, 2 times 8, and 4 times 4. I cannot get to negative 4 in any way. So this one is not factorable from this point, so that means I need to use the quadratic formula. So I go ahead and I'm going to start plugging it into that. So x equals negative b. So the opposite of b is currently 4, so it's 4. It's negative 4, so the opposite is positive 4. 4 plus or minus the square root, b squared, so negative 4 squared, minus 4 times my a times my c, all over 2 times a, so 2 times 1. Simplifying, I get 4 plus or minus, it is, if I do this part, I get negative 48 all over 2. Okay, let's see, perfect squares in 48. 3 times 16 is 48, and it's negative. So I really have x is equal to 4 plus or minus the square root, negative 1, times 3 times 16 all over 2. Okay, square root of negative 1, good old I. Square root of 16 is 4. Okay, can't take the square root of 3, so let's stand underneath there. So what I would have is x is equal to 4 plus or minus 4i square root of 3 divided by 2. Look, these are all divisible by 2. So 4 divided by 2 gives me 2 plus or minus 4 divided by 2 is 2i square root of 3, and then 2 divided by 2 is 1. So x equals negative 4 and x equals 2 plus or minus 2i square root of 3. Those are my answers for example 13. Okay, so it is possible to have some imaginary numbers. That will be it for today's notes. If you have any questions, please write them down, come and ask. Otherwise, have a great day.